Welcome to the Math Record. Today I'll be covering the CCML Precalculus Contest for 2019-2020 Division A. I'll be going through every single question from 1 to 20 in that order, and if you want to look for a specific question, I'll be time-stepping all these questions in the description below. Okay, number 1. Compute secant of 3 pi over 4. Okay, so 3 pi over 4 is just in radians. So that is equal to 135 degrees. How I know it's 180 divided by 40 divided by 4 is 135. I mean, divide by it's 45. So 45 times 3 is 135 degrees. So secant 135 degrees, that's just a 45 degrees. Basically, since secant at 135 degrees is negative right here at the cosine, that means if you kind of draw the side lengths, which let's say this is -1, this 1, right? Because they're the same, then if 45, this will be 1 times square root 2, which is this makes this square root 2. Right? So then secant would be the hypotenuse over that side length, which is -1, is negative square root 2. And that is your answer for number 1. So you don't really have to logic that out. You can like mentally think about it if you do a lot of trig. So it's a pretty simple question. I was just showing my work. Number 2, solve for x. So 4 to the power of x minus 2 is equal to square root 2. Okay, so sorry that I don't have like the actual document, so I wrote it in a Google Doc. So I'll be writing everything out on the blackboard if you can't see. Right? So 4 is 2 to the power 2, so 2 times x minus 2 is 2x minus 4 equals, this is 2 to the power 1 times square root 2, which is the same thing as 2 to the power 1 half, right? Square root is just 1 half. So 1 plus 1 half is 3 over 2. That's just basic log properties. So that means 2x minus 4 equals 3 over 2. Add the 4, so that is 8, so that plus 3 is 11 over 2. So x equals 11 over 4. And that is your answer for number 2. Okay, number 3. Compute the summation x equals -2 to 5, where the function is 2x cubed. Okay, since it's x cubed, that means the graph looks something like this. So when the cube looks like this, since it's an odd function, odd basically means that it's gonna, if you choose a specific point, let's say this is 2, and that means this was -2, so the negative version of this, that means the y value of this point is the negative version of this point right here. So what that basically means is that they're gonna be like the same number, but opposite like signs. So one could be like 2, one could be like 5, and the other one would be -5. Right? So if we write all these out, so -2, -1, 0, 1, 2, 3, 4, 5. The ones that cancel out -2 and 2, and then -1 cancels out with 1, and then 0 is just basically nothing, because 2 times 0 to the power 3 is just 0. So you plug in 3 in there, so we just need to find these 3. It would be 2 times 3 to the power 3 is 27. And then it'd be 2 times 4 to the power of 3, 1664. And then 2 times 5 to the power of 3 is 125. Right? So since they're all multiplied by 2, let's just add these three numbers and then multiply by 2 later on. So 84 plus 27, that is 91. 91 plus 125, that is 6. That's 216. Since we need to multiply by 2, right? That makes 432. And that's your answer for number 3. Okay. Number 4, if matrix, let's write that out, matrix 2, -3, 4, -5 times matrix -4, 3, -2, 1 is equal to matrix A, B, C, D. Solve for A, comma B, comma C, comma D, right? So write these in like that coordinate form. So a matrix is basically just these two multiplied by these two to get A, then that one to make B, and then these two times these two makes a C, and then these two times these two make D, right? So it just follows that pattern. So let's kind of write that out. So 2 times -4 is -8. -3 times -2 is +6. And then that 2 times 3 is 6. -3 times -1 is -3. And then 4 times -4 is -16. And then -5 times -2 is +10. And then 4 times 3 is 12. And then -2 times 1 is -5. Right? So that simplifies down to 2. -2, 3, -6, and 7. Okay, so A, B, C, D in that form is -2, 3, -6, and 7. Okay, and that is your answer for number 4. Okay, number 5. If the 28th term of a arithmetic sequence is 1 and the 12th term is 21, what is the sequence fourth term? Right, so let's keep the terms on top. So 28th, the sequence 1. The 12th term is 21, and we have to find the 4th term. Okay, so let's call that x. So 12 to 28, we have to move a good 16, right? So let's draw that lower because it's kind of hard to see. We have to move 16 from 4 to 8 to 12. We have to move 8. So we're moving half the times. So that means if we're moving half the amount of terms that means we're subtracting half the amount of differences. So from 21 to 1, we subtract 20. So since we're going half, that means instead of minus 20, we're minusing half of that, so minus 10. So that means x minus 10 is equal to 21, so x is equal to 31, right? Just 10 plus 21 is 31. And that's your answer for number 5. Okay, should be pretty simple. Number 6, if sine of theta equals, so sine of theta equals 1/3, so sine of theta is 1/3. Compute cosine of 2 theta. So you just need to know your trig identity. Cosine of 2 theta is equal to cosine 2 theta minus cosine squared theta minus sine squared theta, or 2 times cosine squared theta minus 1, or 1 minus 2 times sine squared theta. It doesn't matter which one you use, but I'm just going to use this one. Okay. You can use any single one. I'll just show you one of them. Right? So sine of theta is 1/3. So using the Pythagorean theorem, right, for trig, which is sine squared theta plus cosine squared theta is equal to 1. So sine of theta is 1/3, that's 1/9, plus cosine squared theta is equal to 1, right? So then 1 minus that 1/9 is 8/9, right? So cosine squared theta equals 8/9. So cosine of squared theta, and then square root it, so cosine theta is equal to plus or minus square root 8/9, right? Okay, delete that. Oops, I forgot to make a template, so I will just reverse. So to find the cosine of squared theta, we gotta square that. So even if it's minus square root 8/9 or positive 8 squared 9, if you're squaring both of them, it's just gonna be positive. So squaring both of them, that just makes 8/9, right? Because square root 8/9 squared is just 8/9. And then minus sine squared theta. So sine squared theta is 1/9, right? 1/3 squared is just 1/9. So that makes 7/9. And that should be your answer for number 6, 7/9. Okay, so let's delete all of this because I forgot to make a template. So, okay, so it's just a few more to delete and perfect. Now I can make a template. Okay, number 7. Solve for x. The determinant of matrix 1, 2, 3, 4x0, and 2, 4, -1 equals to 35. So I'm going to use like a general rule for matrices. So instead of going like 3 down, right, the usual way of doing it, right? So these two and then this, right? So it's got to be these three and then these three and then these three, right? Add those together and then it's going to be these three, then these three, then these three multiplied, right? Add those together and then subtract them to get 35. That's usually the determinant for 3 by 3. I'm not going to do that, right? That's way too long. So what I'm going to do is that I'm going to use the general form. So you got to use 1, 2, and 3, right? So the first one is 1 times. So then you got to do the matrix of the 2 by 2. That's kind of like a way below it. So, well, not really. So 1, where does that touch? It touched these two, right? If you go straight down, right? That means you're using these two. So, and that's kind of how I memorize it. So then x times -1 is -x. And then 4 times 0 is 0, so you got -0. And then we have a 2 here. So the next one, you have to alternate between positive and negative, right? So it's got to be a positive 1, -2, and then positive 3. So then negative 2 times. Now 2, what's that under? X and 4. So we're going to use the 4, -1, and 0, 2. So 4 times -1 is -4, and 2 times 0 is 0, so -0. And then plus 3, that as a matrix goes down, so it's just 4 times 4, which gives us 16. And 2 times x is -2x, right? So this simplifies just -x. So times 1 is just -x. And then it's just -4, so -2 times -4 is +8. And then 3 times 16 is 48. And then 3 times -2x is minus 6x. And that should equal your determinant, so it equals 35, right? I just don't have room on top here, that's why I didn't write it. So then adding the constant terms together, similar terms, so negative x plus negative 6x is negative 7x. And this one's 56, so 35 minus 56. That's negative 21, right? So let's substitute that one in. So x negative 21 divided by negative 7 is 3. And that is your answer for number 7. Okay, see, it's pretty simple. Number 8, log 4 of 2x, 4 of 2x is equal to log 8 of x. So we gotta change this to log 8, right? So using change of base, it's just log of whatever number, let's just call that a because there's already x here, of 2x is equal to log a of 4, and a could be anything. So I'm gonna set a equals to 8. Okay, so log 8 of 2x divided by log 8 of 4 is equal to log 8 of x. Oops, log 8 of x. Ah, that's a little too big. Okay, perfect. So what's 8 to the power 4? When you think about it, it's just 8. Let's call that equal to a. So, right, 8 to the power of a is equal to 4, right? So 8 is 2 to the power of 3, so 2 to the power of 3a. And 4 is just 2 to the power of 2. So a has to be 2/3, right? So that if a is equal to 2/3, that means log 8 of b is equal to 2/3. So we can substitute that in. And then when you divide by a fraction, we're multiplying by reciprocal. So log 8 of 2x divided by 2 divided by 3 is just multiplied by the 2 over 3. So it's got to be 3 over 2 times log 8 of 2x equals log 8 of x. Okay, so when we have a scalar, we could just move it to its exponent. That's just a log rule. So that means log 8 equals 2x to the power of 3 over 2 um, equals power of 3 over 2 equals log 8 of x. So moving that up. Okay, so that tells us that 2x power of 3 over 2 is equal to x, right? So 2 to the power of 3 over 2, x equals power of 3 over 2, distribute that out, equals x, right? And then we would actually divide both sides by x to the power of 3 over 2, right? So then we could cancel out this x over here, so we have 2 to the power of 3 over 2. And then this power 1, so when you're dividing same base with with those exponents, we just subtract. So 1 minus 3 over 2 is gotta be x negative 1/2, right? That's kind of hard to look at. So negative 1/2, right? So then to make this just x, just raise both power to the negative 2, right? So 3 over 2 to the power of negative 2. That's just 2, so the 2 and 2 cancel out, makes negative 3. So x equals 2 to the power of negative 3, which is just 1/8, right? Because it's just 1 over 2 to the power of 3, which is 2 power of 3 is 8, right? So the answer is just 1/8. And that's your answer for number 8. Okay. Number 9. Express x is 0.3, and then the repeating part is 1, 2. So write that as a fraction. So what we have to do is that we're going to have to get 1, 2 on this side. So we're going to have to move the 3, right? We need to move to 3, and then we have to move the 1. So then when we have the 2 here, it's going to repeat 1, 2, right? Because this repeats 1, 2, 1, 2, 1, 2. So 1, 2, 1, 2, right? Etc. So how much places did we move? Well, we move from here to down here, right? So we move 2 places. So we're multiplying by 100. So, right, because you multiply by 100, 1, 2, right? So 31.2, 1, 2, right, etc. So subtracting them, so 99x, 100 minus 1 is 99. And then 31.2. So this part and this part cancel each other out, right? When you're subtracting, because that's where the decimal places lined up. So 31.2 minus 0.3. So we have 99x is equal to 30.9. So then divide by 3 from both sides, so that's 33x equals 10.3. Multiply by 100 and then divide by that number. So multiply by 100, that's 103. Multiply by 10, right? And then 33 times 10 is 330, so divide by that 330. Okay, 330. And that should be your answer. 103 divided by 330, right? So I know this is the simplified form because 103 is actually prime. So you can't divide any further. Okay, number 10. Compute the area of the region enclosed by the graph 2. Okay, so 2x minus 1 squared plus y plus 3 squared is equal to 4. So an area enclosed by this is just going to be an ellipse. So the area of ellipse, the general form is going to be, if there's no change in this, it doesn't really matter what that is. It's just going to be x squared over a squared plus y squared over b squared is equal to 1. And the area of an ellipse is just a times b times pi. Okay, so that's just a formula you need to know. So then basically, to get this equal to 1, we just need to divide by 4. So x minus 1 squared. 2 divided by, that 4 divided by that 2 is just 2 on the bottom, right? And then y plus 3. So there's nothing to divide that by, so there's just a 4 on the bottom. So 4 divided by 4 is 1, right? So square root 2, and square root 4 is just 2, so let's put 2 square root 2, and then multiply by the pi. So it's 2 square root 2 pi. Or you could just write 2 pi times square root 2. Just make sure not the pi is not in the square root, right? So it's only just the square root 2, not the square root 2 pi. Okay, and that's your answer. Okay, number 11. Given the sum of the terms in the arithmetic progression, solve for x. So 2 plus 5 plus etc. Right? So it's going by a common difference of 3. So the formula for a arithmetic sequence, the sum of it, is the sum is equal to the number of terms, so how many terms there are, divided by 2, plus the first term, so term is 0, plus term of the last one. Okay, so following this formula, we have 5, 4, 30 is equal to number of terms we'll calculate later. And the initial term is 2, and the last term is going to be x, right? Because go up to x. So how many terms are there? Well, as I said before, the common difference is 3. So 5 minus 2, that's 3, right? So then let's divide that by 3. That equals 1, right? So 1. There's not one term there, there's 2, right? So we got to add a 1 to this number. So let's think about this. So after a 2 and a 5, the next number in the sequence is 8, right? Plus 3, plus 3. 8 minus 2 divided by 3, that's 6 divided by 3 is 2, right? But there isn't two terms. There's 1, 2, 3. There's 3 terms, right? So we had to add 1. So you see the pattern here? So it's just going to be the last term minus the 2 divided by 3 plus 1. So last term is x minus 2 divided by 3 plus 1, right? Because the total amount of change in common distance divided by that common distance is how much change there is between the terms. So how many terms there are, and then plus 1 gives us the so all that change plus the first term gives us the total amount of terms. Okay, so 530, I mean 5, 430. And then x minus 1, and this 1 is just 3 over 3, so x minus 3 plus 1, I mean x minus 2 plus 3 is equal to x plus 1, uh, parentheses, and then we're going to multiply this by x plus 2. And then this one's, remember, is divide by 3, right? And then divide by 2, so that's divide by 6 overall. So move 6 to the other side, and let's factor this number. So 54 divided by 6, right? Because 54 and 30 could be divided by 6. Um, so 9, 18, 27. Yeah, so that's 9, and then that's 0 and 5 equals x plus 1, x plus 2. So from this, we could have 6 times 6, and 905 could be divided by 5 because I see a 5 there. So that's what 900 divided by 5 is 180, and then divided by that 5 is 1, so 181, right? So we see a pattern here, right? So what's 8 times, I mean 6 times 6, that's actually, let's do 6 times 5 first. That's 30 times 6 is 180. 180 times 181. Well, this is going to be 180 and this 181. Because as you seem to notice already, we have a 1 and a 2 here, right? So this number, since it's just x plus 1 plus another 1, that means this term is just one more than the previous, one more than this one. So that tells us that the numbers have to be separated by a difference of 1. So 180, 181, that works, right? So x for this number, which is the smaller one, is 179. And the same thing here, 179 plus 2 is 181. Right, so your answer for number 11 is 179. Okay, number 12. Simplify to a single trigonometric function. So cosecant of x divided by cotangent of x plus, that looks kind of weird, cotangent of x plus tangent of x. So what does this simplify to? Well, cosecant of x is just sine over 1 over sine of x. And this one is just cosine of x divided by sine of x plus sine of x divided by cosine of x. So then cross multiplying, that's cosine squared x plus sine squared of x, which is just 1. So we have to write that top one first, so 1 over sine of x. So that's 1, and then sine times cosine is sine times cosine. Right, so dividing by a fraction is multiplying by its reciprocal. So sine of x times sine of x. I mean 1 over sine of x times sine of x times cosine of x. Right, moving them both to the numerator. And then cancel out the signs, and then you just left with cosine of x. And that's your answer for number 12. Okay, number 13. Graph the graph of f of x. So f of x is equal to cosecant of x divided by cosine of x and 1 minus cotangent of x. So let's simplify this. So this is 1 over sine of x divided by, this is cosine of x. This is 1 minus cosine of x divided by sine of x, right? So this is also, you can simplify cosine of x times sine of x minus cosine of x divided by sine of x, right? Which is just, these two are the same. Let's move this up so I get a little bit more room. So you can simplify that part. It's just 1 over sine of x divided by, because it's divided by sine of x, so dividing by, if you kind of extend this, it's just cosine of x times, in parentheses, right? Extend this out. It's just sine of x minus cosine of x in that parentheses divided by sine of x. So they're both divided by sine of x. All we have to do is just multiply by sine of x from top and bottom. So all you have is just that 1 from here, and then you're left with cosine of x times sine of x minus cosine of x. Okay. So now we have to look for when does this equation become undefined, because that's going to give us our vertical asymptotes, right? So our asymptotes is what we're looking for. So cosine of x, when is that equal to 0? Well, that is equal to 0 when x is equal to pi over 2 and 3 pi over 2. 3 pi. Okay, so that looks terrible. 3 pi over 2. And when is sine of x equals cosine of x? Well, that's only at the 45-degree angles, so it's going to be at pi over 4 and 5 pi over 4, right? So when they're both positive and when they're both negative, right? It's not going to be like 3 pi over 4 and 7 pi over 4 because one is positive and one is negative, right? So those don't work. So we have these four. So we have a total of 4 answers, right? But you're asking yourself, doesn't like when x is equal to 0, it's gonna be undefined, right? Because cosecant of x of 0, that's undefined, right? Well, actually, the reason it doesn't work is, remember, it was 1 over sine of x, and then it's this over sine of x, right? So that's where it's gonna be 0 and 2 pi. So wouldn't that be 6 then? Well, actually no, because these are actually gonna be wholes, so it's gonna be different. So when you divide it out and these things cancel out from those functions, the zeros of those functions basically gives us something with holes. So it's gonna be look something like this, right? So there's like a line and there's a hole in that graph at that part point, and then it's gonna be like, and it goes on, right? So everything's defined except that point. Okay, so only 4 exist. Okay, and that was for number 13. Number 14, if log 10 of 7, so let's work that out, log 10 of 7 is approximately 0.8, 0.845. How many digits are in the base 10 representation of 7 to the power of 300? Right, so we have some kind of, let's say, 5 times 10 to the power 2. So how many digits does this have? Well, if you kind of do the math, that's just 100 times 5 is 500. There is, oops, I wrote 5,000, equals 1, 2, and 3, right? There's 3 digits. Well, there's 3 digits. 2 to 3, we just add 1. Okay, so let's kind of do that again. Let's say we have 2.3 times 10 to the power 2. That is just 230. How many digits there? 1, 2, 3. 2 to 3. So even if we change this, it doesn't matter, right? So we're writing in scientific notation, right? So now let's try something like let's change this exponent. Maybe it's just a weird exponent. Let's say it's power to like 3, and we're gonna use like 1.3 now. So that's gonna be 1, and then move 2 more decimal places. So we have 1, 2, 3, 4. 4. So we always seem to be adding 1 to the exponent. And that's basically what it is. The pattern is whatever the exponent is, this exponent plus 1, that should give you the amount of terms. And that's just going to work all the time. And that's why they're going to give you this log 10 of 7. So how we kind of do this is we're going to have to convert 7 to the power of 300 to a log 10. So in scientific notation, we have a, right, some kind of number, times 10 to the power of x, which is what we're looking for. We're looking for x, is equal to 7 to the power of 300, right? And a has to be between 0 and 10, right? Because scientific notation, it cannot be higher than 10. If it's higher than 10, then this increased by 1, right? The exponent increased by 1. So that's between these two numbers, right? And it can't be lower than 0 because it has to be positive. So when you do the log of both sides, right? So log 10 of a times 10 to the power of x equals log 10 of 7 to the power of 300. Um, this is basically just log 10 of a plus log 10 of 10 to the power of x, right? That's just log rules. So simplifying this part, that's just log 10 of a, and then bring the exponent down. So log 10 of 10, right? That's just 1, so we don't have to write that down. Okay. So I'll bring the exponent down, same thing here. So 300 times log 10 of 7. Well, where will we see this? Well, we see it right here, right? And that's the reason why we're going to use it and why there's decimals. So how do we interpret these decimals? We're looking for x, right? Why is there decimals? Well, the reason is because we have a log 10 of a. A is between 0 and 10, right? So it's not going to multiply evenly to 10. So if a is between 0 and 10, right, then this number is going to be between, right, because a is between 0 and 10. That means log of any numbers from 0 to 10, that's just going to go from 0, right, some kind of like number that doesn't make sense, to 1, right? So what that kind of looks like is that from 0 to 1, that means it gives us a number that's a decimal. So we have a section of this that is a decimal plus x. This x is an integer. Yeah, plus an integer, right? And that will give us a decimal, which is equal to this side. So what that is telling us is that if we want to just find x, we just need to ignore the decimal part. So let's kind of just do the math on this, right? So we have 300, right, times log 10 of 7. 10 of 7 says 0.845. So 100, 300 is just 100 times 3. So move 2 decimal points, so 84.5, and then multiply by 3. So that's 15, 1, 12, 13, 1, 24, and then 25. So 200, okay, that looks kind of ugly, so I'm going to rewrite that again. So 253.5, right? So we see that decimal. We're going to ignore it. And then remember, x is the exponent. We have to add 1 to it to get our thing, right? So 253 plus 1 is 254. And that should be our answer. And that works all the time. Whatever you have as a base raised to a power, just have that power times log 10 of that number, get the integer part, and then add 1. That should be the amount of digits. It works all the time. Okay, and that's kind of like the proof of how to do it. Number 15, the first term of an infinite geometric series is 2, and the fourth term is I divided by 4. What's the series sum? So we have 4 terms, right? The first term, the second, the third, and the fourth. So the first term they gave us is 2, and the last term is negative I or 4, right? So how do we get from 2 to 1/4? Well, it seems to have something to do with 2's, right? So let's divide by 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2. And 1/2 divided by 2 is 1/4. Okay, so we know we need to divide by 2. Or we could just basically multiply by 1/2. Okay, so we need to get to the I. So how do we do that? Well, let's just kind of use I already. So let's say it's instead of 1 over 2, it's I over 2. So 2 times I over 2, that's I. I times I over 2. So I squared is just negative 1, so negative 1 over 2. And then negative 1 times I is negative I, and 2 times 2 is 4. Okay, so that works, right? So you could just do it with trial and error. Because if it's not I, then it's probably only going to be negative I, right? So now we know what our ratio is. So this is our ratio, and this is our first term. So the sum of an infinite geometric series is going to be the first term, right? The formula is just going to be the first term divided by 1 minus the radius. That is the sum of an infinite geometric series. Only for an infinite geometric series. It has to be infinite. So you can't use it for a regular geometric series. So first term is 2, and then our ratio is I divided by 2. So this is just 2 minus I over 2. So 2 minus I over 2. So that's just 4 over 2 minus I. So multiply the top and bottom by 2 plus I. Okay, so that's just 8 plus 4I. And then that's 4. Positive 2I minus 2I, so that cancel each other out. And then negative I times I. Remember, I squared is negative 1, so negative 1 times that negative 1 is positive 1. So 4 plus 1 is 5. All right, and you could just leave it like this. So it's 4 plus 8 plus 4I divided by 5. Okay, so number 16. An ellipse has the equation x plus 4 squared divided by 100 plus y minus 2 squared divided by 36 is equal to 1. And a parabola has the equation y equals x squared plus bx plus c, right? In case you can't see it, I'm writing it out. If the parabola passes through both the foci of the ellipse, determine the coordinates of a vertex. So since I see that the bigger number 100 is bigger than this number 36, that tells me that the graph is gonna be since it's an ellipse, right? It's gotta be like a circle, but it's gonna be more like an oval actually. So since we have 100, which is bigger than 36 and is under the x, that means the x is the part that's bigger or longer. So it's positioned at negative 4, 2, so negative 4, 2. And then we have something like this, right? So this part is longer than this part. Okay, so the vertex are right here. I'm just bad at drawing, so it's kind of perpendicular, and these are the same. And then where is the foci? Well, the foci is like somewhere right here. So how do we find that distance? Well, the distance is just gonna be the bigger number, which is 100, minus the small number, which is 36, and then you take the square root. So that is 64. Square root 64 is 8, plus or minus 8, right? So plus or minus 8 is because we have 2 points here and here. That's why it's plus or minus 8. You have to move from the x. So the center is at negative 4, 2, right? So plus or minus 8. So it's got to go through, let's say minus 8 first. So that's minus 12, 2. And then plus 8, which is 4, 2, right? So those are our 2 points. So let's kind of delete the picture of that because we don't need it. So now looking at this, right? What do we do with this? Well, if you kind of look at the parabola, the equation of the parabola, the coefficient is 1, right? So all we need to do is just have x, since the coefficient is 1, it's just going to be something like this, plus some kind of number inside, squared, plus like some number constant outside, right? So we know that's 1, so we could just leave it and not write it, so x plus something. So where does this go through? Well, if you kind of draw the graph of this one, the two foci is negative 12, 2, and 4, 2, right? So it's something like this, right? Concave up. Because this is positive, so it's concave up. So since this is the same height, that means that the vertex has to be right between these 2 points. And remember, we just minus 8 and plus 8 from negative 4. So center is just going to be at the negative 4, right? So plus 4, because negative 4 plus 4 is 0, squared. So y equals, right? And then we just had to plus a, and then we had to find what this k value is, right? And all you have to do is just plug in a point. You can plug in any point, it doesn't matter. So let's plug in negative 12, so that's negative 8. Negative 8 squared is 64. We need to get from 64 to 2, right? So we have to minus a 62. And that tells us that our vertex is going to be at negative 4, negative 62. And that is your answer for number 16, right? Which is our vertex, negative 4, negative 62. 17. Triangle ABC is a cubic triangle such that AC is equal to 2AB, BC is equal to 10, and sine of A is equal to 12 over 13. So for AB. Okay, so let's draw a picture, because usually for geometry I like to draw pictures. It gives you a visual idea of how to do it. So A, B, and C. So let's say AB is X, right? That means AC is equal to 2X. So BC is 10. And sine of this angle is 12 over 13. So sine of angle A equals 12 over 13. And we need to look for AB. So AB is x, so we just need to find x. Okay, so how do we do this? Well, you could use something called log cosine, which basically gives us opposite, whatever the theta is, so this theta, opposite of the theta, the side length, it's just basic, we just follow the formula. So it's c squared equals a squared plus b squared minus 2ab cosine of theta, right? A and B are just the side lengths that connect the angle, right? It doesn't matter which one's which. And C is the side length that's opposite of that angle, so it's the 10. So plugging into this formula, we have 100 squared, 10 squared, which is 100, and then a squared, which is, let's say, the x, which is x squared, and then 2x squared is 4x squared, minus ab, so 2x squared times 2 is minus 4x squared. Cosine of theta. Well, we only have sine of theta, so that means cosine of theta. If you think about it, this is a Pythagorean triple. It's actually the 5, 12, 13. So if the sine of theta is 12 over 13, that means the cosine of theta is 5 over 13. Okay, which is just good to know. You just know your like a few of the Pythagorean triples, so you don't have to do all these math. So cosine of theta is 5 over 13. Okay, so we don't need all this anymore. We just need to solve for x now. Okay, so 100. This is 5x squared, and then 4 times the 5 is 20 over 13x squared. This is 65 over 13. So 65 over 13 minus 20 over 13 is 45 over 13. Okay, so we have 100 equals 45 over 13x squared. So multiply 13 over 45, right, to get our x squared. Divide by 5, so that's 20, so that is a 9. And since we have to take a square root, let's factor this out and say that's 4 times 5. So then square root of 4 is 2, and you can't take a square root of 13 or 5, so you're going to be inside the radical, so it'd be 13 times 5, which is 65. And square root of 9 is 3. So that is our x. And our answer is 2 square root 65 divided by 3. Okay, and that was from number 17. Number 18. Suppose that 2 to the power of x is equal to 27. And since I see 27, I'm just gonna write 3 to the power 3. Because usually when CCML kind of does this, you gotta have to factor. And they say that x is equal to 3/4 y minus 12. So if y is equal to log 2 of z, what is the prime factorization of z? So we have to find y, right? We're already given x because we just need to move it around. So log 2 of whatever this number is, so in the parentheses, 3 to the power 3 is equal to x. Okay, now let's plug that into here. So log 2 of 3 to the power 3. And then move to the negative towards the other side so it becomes the positive 12, right? And since we want this to have the same log, right? Log of 2, we're going to have this as log 2 of 2. Because log 2 of 2 is just 1. So 1 times 12 is just a 12, right? So it does nothing. And then we have 3/4 y. Okay, so we're going to do the same thing. We're going to 3 to the power 3. Scalar, you can always put it as the exponent. So we're going to have log 2 of 2 to the power 12 equals 3/4 y. And then when you're and then parentheses, and then when you're adding logs that have the same base, we actually just multiply them. So 2, so it's 3 to the power 3 times 2 to the power 12 is equal to 3/4 y. And then we can multiply both sides by 4 or 3, so we cancel this out. Right? And then a scalar, as I always said, could go to the exponents. So it goes to the exponents of both of them, right? Because they're both in the parentheses. So 4/3 of, so 4/3. Okay, that looks bad. Okay, so 4/3 times 3 is just 4. So that's, oops, that is a 2, sorry. So that's going to be 3 to the power 4. And 12 times 4/3, so 12 divided by 3 is 4. 4 times 4 is 16. So that's 2 power 16 equals y, right? So so we found y. So y equals log 2 z. So we have a log 2 here. And our z is equal to 3 to the power 4 to 2 to the power 16, right? 16. Right? So find the prime factorization of z. Well, this is already prime factorized, right? the primes are 3 and 2, and then just raise to the power. So it's 3 to the power 4 times 2 to the power 16. Or you can write as 2 to the power 16 times 3 to the power 4. It doesn't matter. Just make sure that it's these numbers. Okay. And number 19. If 3x squared, let's write that out, 3x squared minus 5xy minus 2y squared minus 17x minus y plus f is equal to 0 plus f determines a degenerate convex. Solve for f. So a degenerate convex it's basically that there's only like a few points that work. So a convex by itself is either a ellipse, a hyperbola, or a parabola. So how you gonna tell which one it is? There's only three of them. So a hyperbola, it's degenerate. It's gonna be two lines, and a ellipse. So ellipse is a single line, and a parabola, its degenerate is a point. So which one do we use, right? And how you could tell is that you just look for the x squared terms. I mean the squared terms. So you have x squared and y squared. So since there's both of them, it's not gonna be a parabola. And the reason is a parabola only has one term that's squared, right? Because have you ever seen parabolas, right? As you notice, because you always work with parabolas, there's only either a y squared or x squared. There's not both of them. If there's both of them, then it's either a hyperbola or ellipse. So how do we know which one's which? Well, the 3 here is positive, and the y squared here is negative, right? Negative 2 and positive 3. If there's different signs, then it's a hyperbola. If it's the same signs, like if they're both positive, then it's ellipse. Or is it both negative? It's an ellipse. Okay, so we know it's a hyperbola, so it's going to be two lines. Okay, so we know that. So how do you get two lines from here? And how do you set up an equation with two lines such that we have x y terms, y squared terms, and stuff like that? Well, it's actually going to be x plus y plus some kind of constant, x plus y plus another constant, right? So we have two lines, right? And that's equal to 0. And we're going to get x squared terms, we get y squared terms, we're going to get xy terms, right? We're going to get some x terms, we're going to get some y terms, right? And we're going to get some constants, right, which is our f. So this gives us everything. So it's not going to look exactly like this. So this is a general form. We're going to have to find its coefficients. So how do we get the 3x squared? 3 can only be multiplied by 1 and 3, or negative 1 and negative 3. But since we're just going to be lazy, we're just going to use the positives, right? So if it's not going to be 3, we're just going to use negative. But it's really unlikely that ever happens. So now we're going to have to focus on this number, right? Because our y squared now. So our y negative 2. So it's going to be like either a negative 2 and a positive 1, or a negative 1 and a positive 2. So how do we get negative 5? Well, since we need it to be a bigger negative, that means that 3 has to go with the 2. So 3 times 2 is negative 6. 3 times negative 2 is negative 6. And then plus that 1 is negative 5, right? So we had 3 with the negative 2, so minus 2y. That means the plus y is this side, right? So that's going to be our 3x squared. This is gonna be our minus 6 minus I mean negative 6xy and our xy, so that adds up to negative 5xy, and y times negative 2y squared is gonna be a negative 2y squared, right? And now let's plus this a and plus and b, because we have to look for constants. So we got these two terms that are already correct. So now we just need to make sure these two are correct. Okay, these two, our x and our y's. So where do we get our x's? It's just gonna be 3x times b, so 3b, right? That's gotta be one of our x's. And the other x is a times x, so it's plus a, so it equals our negative 17. Now how do we get our y term? Well, we see a y right here, so y times the b, so it's gonna be b. And the other y here is negative 2y, so then negative 2 times this a is minus 2a. And then negative 1, right? So those are the only y terms. So solving this like a system equations, multiply the top equation by 2 so we could cancel out the a. So that's 6b plus 2a equals negative 34. Add it with the second equation, so that's 7b. Cancel out the 2a and minus 2a, cancel each other out, and negative 34 plus negative 1 is negative 35. And that gives us that b is equal to negative 5. So b is negative 5. Let's plug it back into this equation. So negative 1 plus that 5 equals 4, and 4 divided by negative 2 is negative 2, right? So that's our a. And so to find f, the only constant term is a times b. So a times b is equal to -2 times -5 equals 10. So if you're not sure how I did it, just kind of factor this out, and you see that it kind of makes sense logically. I'm not gonna show the work of why these are the only like terms, how to make the x and the y's and like the constants. If you just expand it out, equals 0, right? Instead of equal to this one, just make sure all the like numbers match up, right? And you should get out that your which is a times b, is 10, which is your answer for number 19. Okay, number 20. Let M be a n by n matrix. Okay, a scalar, I think it's called lambda, I'm not exactly sure, is called a eigenvalue of M if there exists a n by 1 matrix C such that MC is equal to lambda times C. Compute all eigenvalues of matrix 1, 2, 3, 4. So plug it in, so our M, right, using that formula, MC equals lambda C, which is 1, 2, 3, -4. And our C, right, what is C? C is a n by 1 matrix, so it's going to be a 2 by 1 because our M is a n by n. So our n is a 2 by 2, right? So our n is 2, so our C is going to be a 2 by 1. So 2 by 1, let's call that xy, right? And then lambda, lambda is some kind of scalar, so let's call that k. And lambda is multiplied by a matrix, so it's just a scalar. So you just multiply k by x and k by y. Okay, so just remember lambda is k. So they're saying that a scalar lambda is called an eigenvalue of M if there exists a n by 1 matrix X. So they're basically saying K, you have to find K when there exists at least one possible value of xy that satisfies this equation. So how do we find that? Well, basically, an answer that I'm not exactly sure if they kind of wrote it kind of wrong is, since they never specified, is that there's infinite amount. Because if x and y is 0, right, 0, anything multiplied by 0 is always going to be 0. So it's always going to end up, whatever you're going to multiply a 2 by 2, any 2 by 2, is always going to end up at 0, 0. So whatever k you can plug it in. It doesn't matter. It could be like 1, 2, 3.5, like some kind of like e or something, pi, right? It doesn't matter because anything multiplied by 0 is 0. So there's technically always going to be 1 because if there exists an n by 1, and there does exist 1, is 0, 0. So that's probably just a fallacy with a question. But if you want to solve it earnestly, how you kind of do it is that you just actually do the matrix. So 1 times x is x, and then 2 times y is 2y, and then 3 times x is 3x, and then -4 times y is -4y, right? So that's just basic arithmetic multiplying. Then kx and ky. So now you have to set them equal to each other, and ky. And now we're going to combine like terms. So x and the x combine. So 2y equals k. So that's just minus kx minus x, so just k minus 1 times x. And this is the y, so let's move this x this way. So it's gotta be k plus 4 on this side. Right, so all I did was move this to this side, and then I switched the places of both the right and the left side, so then I can match up the x with the x and the y with the y. Right, so it looks a little bit nicer. Okay, so we don't need this anymore because we already simplified to this part. So now, how do we find k? Well, let's first kind of make this like an equation. So the first one is just be k minus 1 divided by 2 equal times x, and the other one's y equals 3 divided by k plus 4 times x, right? So that tells us, since if we want the equations to be the same, right, then we have to have the slope the same, right? Because if you just kind of set the equal to each other, y is equal to y, and then you set these two equal to each other, right? So k minus 1 divided by 2x equals 3 over 4x divided by this. So your slope has to be the same. But you could just logic through your way and just say that the slopes are the same, right? Because you have the same y here, the same x here, so you have to keep these the same. So k minus 1 divided by 2 equals 3 over k plus 4. Okay, so let's move this up. So now we could cross multiply. So k minus 1 times k plus 4. So k times k is k squared, plus 4k minus k, that's plus 3k. And then 4 times -1 is -4. And 3 times 2 is 6. So that tells us that k squared plus 3k Minus 6 is minus 10. Sorry about that. And K, I need water, but I'll drink later. Okay, so minus 10. So we need a positive, so we're gonna have the plus 5, which is the bigger version, so that's the positive one. And then K minus 2, right? So that's gonna be K squared, and then plus 5K minus 2K, 3K, right? And then minus 10, right? So that's correct. So K equals negative 5 or K equals 2, right? And those are your two possible answers. Negative 5, 2, right? So if they add the rule that the matrix C cannot be 0, 0, right? And that basically solves every question from 1 to 20. Well, if you have any disagreements, put them in the comments below or send me an email. And if you have anything else to say, just put in the comments. It doesn't really matter. Well, thanks for watching, and I'll see you at the next math record.